Hello, can you hear me?
What about you?
Hello.
Can you hear me? Can you hear me?
Yeah, I can hear you, but your voice is very slow. It's okay. Let's start it.
Okay. Before that, to test it, I've transferred 1 rupee from my account. Can you please check whether you have received it?
Okay, I'm just checking. Yes, got it.
Fine then. Go ahead.
Okay, let's start it.
Yep. Yes.
So today we'll do various operation on matrices. So obviously we'll do on whiteboard. Okay. So first of all, we'll do topic transpose of a matrix. We can find transpose for any matrix like square or non-square for both. Let matrix A having element A1 B1 C1 A2 B2 C2, and we need to find its transpose. So transpose of matrix A is denoted by this A dash, or in some book they use this symbol, or in some book they use this symbol also to represent transpose. But most common symbol is this.
Okay.
To find transpose of a matrix, we just convert either rows into column or columns into row. So let's convert rows into columns. So A1, B1, C1, A2, B2, C2. This is transpose of a matrix A. Okay.
Yes.
Next is trace of a matrix. Next topic is trace of a matrix. Then we'll do addition, subtraction, and multiplication. Trace of a matrix, just add elements of diagonal, like let matrix, and we find for only square matrix. Okay, we find trace of a matrix for only square matrix, and for transpose we can find for any, for rectangular and square for both, and here it must be square. So let matrix A having element A1 B1 C1 A2 B2 C2 A3 B3 C3. Then trace of a matrix denoted by this symbol, and this means just add diagonal elements only. A1, or we A1 plus B2 plus C3. So this is trace of a matrix. Okay.
Okay.
Shall we use any values example, or you got it?
Go ahead. Go ahead. Not required. Not required.
Okay. Next, let us do addition and subtraction on matrices. So let us understand this by using example. Let matrix P having element to add or subtract matrices, we must have matrices of the same order. Only then we can add them. Okay. So let us take this matrix P having element 5, 7, 2, 4, and matrix Q having element 3, 5, 1, 2. So P minus Q, P plus Q, 5, 7, 2, 4 plus 3, 5, 1, 2. We'll add corresponding elements. Corresponding elements means we just add 5 with 3, 7 with 5, and 2 with 1. Means elements of the same place in both matrices. And 4 with 2. Are you getting me?
Yes, yes, yes.
So we have P plus Q, 8, 12, 6. So this is P plus Q. Similarly, we subtract. So shall I
Understand.
do subtraction or you got it?
No, I got it. I got it.
Okay. So now let us do multiplication. First is scalar multiplication. Scalar multiplication means, for example, let we have matrix A having element 5, 4, 3, 1, and we need to find 5A. 5A means we multiply 5 with this matrix. That means we need to multiply all elements with 5, like 25, 20, 15, and 5. So this is said to be scalar multiplication. Okay.
Understand.
Next, multiplication of matrices. Next topic is. Multiplication of matrices is completely different from addition and subtraction. So let us start. Let matrix A having elements 3, 5, 6, 4, 1, 2, and matrix B we have 7, 3, 2, 5, 4, 1. See, to multiply matrices, number of columns in first matrix must be equal to number of rows in second matrix. Only then we can multiply. We can have as many as row in first or having also single row, but as number of rows in first matrix must be equal to number of columns in first matrix must be equal to number of rows in second matrix. Only then we can multiply, otherwise we can't. Okay, so let us multiply E. Why we need both of them equal? I'm telling you. See, we multiply first row with first column. How? 3 multiply with 7 plus next element 5 multiply with 3, 6 multiply with 2. Are you getting?
Yeah, I can, I can.
Okay. So, and we multiplied first row with first column. Now multiply first row with second column with the same way. So 3 into 5 plus 5 into 4 plus 6 into 1. Now multiply second row with first column, then with second column in the same way. 4 into 7 plus 1 into 3 plus 2 into 2. Now second row with second column. 4 into 5 plus 1 into 4 and plus 2 into 1.
Understand.
Yeah. We have here 3 into 7 plus 5 into 3 plus 6 into 2. So we have 48. So A into B, first element is 48. Next, um, 3 into 5 plus 5 into 4 plus 6 into 1. So we have 41.
Right, 41.
4 into 7 plus 3 plus 4. So we have 35.
Correct, correct. Next is 26.
Yes. 26. Yes.
So if I multiply 2 by 3 and 3 by 2 matrix, I get 2 by 2, right?
Yes. So in product of matrices, we will have always a number of rows according to first matrix and number
Hmm.
of columns according to second matrix.
Okay. So if I
Okay.
multiply
So here
2
we
by
have two rows and in second we have two columns. That is why we got this 2 of 2 by 2. Okay.
is it correct that 2 by 3 into 3 by 2 matrices will become 2 by 2? Will this formula
Not
applicable for
possible
right?
always. You need
Okay.
to check it. See, you need to always check it. Not always possible to multiply any of any order matrices because you just check it. Number of columns in first, okay,
Hmm.
must be equal to number of rows in second. You know why? Because we multiply as so if we have like any more in first, like we have one another element here, and how we multiply because we have only three. Okay, so check it. Just number of columns in first matrix must be multiplied in number of rows in second. Only then we can multiply with this order. Okay,
Understand.
and now you have here three rows, but you can have any number of columns here. Okay,
Hmm.
this is
Hmm.
must. You have here three rows according to this.
Hmm.
You can have any number of columns here, not an issue.
Right.
Similarly,
Right.
you can have here any number of rows.
Hmm.
Okay, but columns we have only three, so you must have here three rows.
Hmm.
Got it?
Got it. Got it.
Only then we can multiply. Okay.
Okay.
Now, next topic is determinant of a matrix. Let matrix A, the standard form having element A11, A, oh, we can only find determinant for square matrix only.
Mhm.
And then determinant of A, this is denoted by this symbol, determinant of A, but most common is this symbol. Most common is this. So first of all, we'll write these elements in this form, in this bracket, and just multiply diagonal elements first, then take negative sign, then multiply another diagonal elements. What it mean? Determinant of A is just multiply A11 into A22 minus A21 into A12. You got it?
Yep.
Yeah.
You're
This is
multiplying the
for
die.
2 by 2 only. Yes, we are doing first for 2 by 2. Okay, because this is 2 by 2 matrix and sorry, 2 by 2. Now we'll do for 3 by 3 because 3 for 3 by 3 this is little bit different from this. So let us understand this. For 3 by 3 order, let mm, standard form having element A11, A12, A13, A21, A22, A23, A31, A32, A33. So determinant of a matrix denoted by the symbol. First of all, we will write elements in this form. So to find determinant of this matrix, take first element this A1, A11. This is element of first row and first column. This is element of first row and first column. So leave the elements of first row and first column and write down these elements in the form of 2 by 2, like A22, A23, A32, and A33. Take negative sign. This is like formula you can understand. So
Okay.
this element is negative. We'll take first is positive, next is negative, and last will be also positive. So this is element of first row and first column. So we leave elements of first row and first column and write down left these element in
Okay.
this 2 by 2 plus next element is, so this is element of first row and third column. Just leave the elements of first row and third column and write down these elements. A21, A22, A31, A32. Okay, and we'll solve these 2 by 2 as previous method. Okay,
Okay. Okay. Understood. Understood.
same as this. Okay, then you
Yeah.
can find determinant of 3 by 3 matrix. You got it now?
Okay. Understand. Understand.
Okay. Now next topic is inverse of a matrix.
Can I ask a question?
Yes.
Why there is no division?
Yeah, I'm going to tell you this. Okay.
Okay.
I'm
Okay.
going to tell you this inverse. We don't
Okay.
have division in here in matrices. We have inverse. By using inverse, we can find division. You can say like if we need to find division like A over B, then we'll do as B inverse into A. Okay.
Mm-hmm.
Yes. So here we use inverse instead of division. Okay, we don't have division in matrices. We use inverse instead of that.
Okay.
Okay. Yeah. So inverse of a matrix. So let A be any square matrix because we can find inverse for only square matrix.
Okay.
Then inverse of matrix A is denoted by this symbol A inverse, and this is 1 by determinant of A into adjoint of A. So we already know how to find determinant. Now we need to know how can we find this adjoint. Okay.
Okay.
So adjoint of a matrix, let us know. So first of all, we'll do for 2 by 2. So let standard form of 2 by 2 matrix having element A11, A12, A21, A22. So adjoint of matrix A is equal to we just exchange these elements, okay, and take opposite sign of these elements to find adjoint of A.
Mm-hmm.
A22 and A11 minus A21 and minus A12. This is
Mm-hmm.
adjoint of 2 by 2 matrix.
Okay.
Now let us do for 3 by 3. 3 by 3, adjoint of 3 by 3 is completely different from 2 by 2. Okay, so let matrix A having element A11, A12, A13, A21, A22, A23, A31, A32, and A33. So adjoint of matrix A is equal to C11, C12, C13, C21, C22, C23, C31, C32, C33. And now we need to find in these elements from C11 to C33. So let us understand what they are. So to understand that, we need to understand minors and cofactors also. So minus here, and here we are finding cofactors. So minus first M11 means we are taking for first row and first column. So we leave these elements as previous. We take these elements. See, we have done for all at that time to find determinant only for this row. Now we need to do for all. Okay. So
Mhm.
M11 just leave elements of first row and first column and take rest off. So A23 and A32 and A33. And cofactor C11 is equal to minus 1. This is formula you can take as
Okay.
minus 1 to the power 1 plus 1 and just multiply M11 here. Okay, value of M11 because 1 M11 is determinant of 2 by 2. Okay,
Okay. Okay.
M12 just leave element of first row and second column. So we have A21, A31, A23, and A33. And C12 is just minus 1 to the power 1 plus 2 because we add them. Okay, here. So
Okay.
you can take accordingly. If you have even power, then you will get positive. If you have
Mm.
odd power, then you will get minus sign. Okay, and here
Understood.
just multiply M12. Similarly, M13, leave element of first row and third column. You have A21, A22, A31, A2. Similarly, A3, C3, C13 is minus 1 to the power 1 plus 3 and just multiply M13. Now
Understood.
M21 is just leave the element of second row and first column. So
Yes.
leave element of second row and first column and use the rest of A12, A13, A32 and A33, C21. So minus 1 to the power 2 plus 1. And you need to find in this all. Okay.
Mm.
So you got it all, or shall I explain you?
No, no, good. I'm good. I'm good.
Okay. So next topic is solution of system of linear equation by using matrix inversion. Okay.
Mm.
So
Okay.
let's do. I'm taking the next whiteboard. Solution of system of linear equation by matrix method, or we can say by matrix inversion method.
Mhm.
By matrix method, or sometime we can say matrix inversion method also, because we use inverse of matrix.
Mhm.
So let us take a system of linear equation. Let a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. Then above system of equation can be written as ax is equal to b, and where we can write this system in the form of matrix as, and where a is equal to coefficient of x and y. Coefficient means these values a1 b1 a2 b2, which we have along with x and y. So here matrix A is coefficient of x and y, a1 b1 a2 b2, and this matrix is having unknown variables x and y, and matrix B is right side values c1 c2. This is, so solution means we need to find unknown variables. Okay, so we have this form ax is equal to b, then we need to find this x is equal to a inverse into b. Okay, So to find solution, we need to find first A inverse, then just multiply with B, then you will get the answer. You got it? Or shall we do one example?
Uh, Maybe a small example is fine.
Okay, sure. So we
Simple
need to solve
example.
this. Yeah, I'm using of 2 by 2 only because 3 by 3 is too long. So we are using 2 for 2 by 2. So 2x plus y is equal to 5 and x plus 2y is equal to 4. And we need to solve this equation by using matrix inversion method. So above system can be written as in the form of above system ax is equal to b, where we'll take this a coefficient of x and y. So here coefficient of x is 2. We can't see here any coefficient, so just take 1, okay, for this, because y can be written as 1 into y. So
Right,
that
right.
is why we are taking here coefficient of y is 1. So coefficient of x is 2, coefficient of y is 1 in first equation, and coefficient of x is 1 here and here too. So to solve any system of equations, first of all, you need to form determinant of this matrix, because if determinant is non-zero, only then you can find the solution.
Hmm.
And capital X is having these two variables, x and y, and this b is having right side values, these values. Okay. So determinant of a, because solution, we have solution is x is equal to a inverse into b. So to find a inverse is equal to, we have 1 upon determinant of a into adjoint of a. That is why we need this determinant of a. So determinant of a, just put the elements of this matrix in this form, having 2, 2, 1, 1 here. So determinant of a, just multiply these diagonal elements first, 2 into 2 minus 1 into 1. We have 3. Now we need to find adjoint also, because we did adjoint also. Adjoint of a, just exchange the elements. So we have all same elements, so if we exchange, then also we'll get the same, and just take opposite sign of these two elements. So 2, 2 minus 1 and minus 1. So inverse of a, we have 1 by 3, because determinant of a is 1 by 3, and take adjoint of a. So now we need to find solution. We need to multiply a inverse into b. So x is equal to a inverse into b. So x is having elements x and y. A inverse is 1 by 3 into 2 minus 1 2, and just multiply with b, and b having element 5 and 4. So now just multiply. Mm, okay, let us do on next page. So x and y is equal to 1 by 3, and having element 2, 2 minus 1 into 5 and 4. So 1 by 3, just multiply this row with this column. 2 into 5 minus 1 into 4. Now minus 1 into, sorry, multiply the second row with this column. So minus 1 into 5 plus 2 into 4. So we have here 10 minus 4 and minus 5 plus 8, and 1 by 3 we have 6, and see here. Now just multiply this 1 by 3 inside.
Mhm.
1 by 3 into 6 and 1 by 3 into 3. So obviously we have 2 and 1 here. So just compare elements on both sides. So first element x is equal to 2 and second element y is equal to 1.
Okay.
So x is equal to 2 and y is equal to 1, and this is the solution.
So in this case, only the determinant should not be zero, right? That is the only rule.
Pardon?
Okay. If the determinant of matrix should not be zero because we are doing one
Yes,
by.
yes. Only then
Okay.
we can find. Otherwise, this will become undefined, because
Okay.
when we divide any number with 0, then we'll get undefined value. That is
Okay.
why we need to find, we need non-zero determinant.
Okay. So one question is, can you hold this question in the future classes? If suppose, because I know a little bit about the equation, suppose.
I'm not getting you. Your voice is not so clear. Can you type me, please? Can you type, because your voice is not so clear? Sometime I can hear you, but sometimes it is breaking. So,
What about now? What about now?
yeah, sometime I can hear you clearly, but sometime when you once.
Let me check. Okay, fine. I'll clear it later. Okay, I'll ask my question later. Go ahead. You complete your class. I'll ask in the WhatsApp.
Hello.